Okay, so we are officially going into the second part of this course, which will be the rendering section. So before we get into Cinema 4D, I thought I'd take a couple of minutes just to kind of explain what rendering is and how it works and how the process usually looks like. If you are a more experienced user of Cinema 4D or kind of have a good grasp of rendering in general, then maybe scrub to the part of this lesson where we'll get into Cinema, because we will be doing some render setting changes that might affect your process down the line in this course. So just kind of make sure that you at least stick around for that. So yeah, just to kind of explain to you what 3D rendering actually is. If you Google what does 3D rendering mean, this is kind of the result that you'll be given. 3D rendering is the 3D computer graphics process of converting 3D models into 2D images on a computer. 3D renders may include a photorealistic effect or non-photorealistic styles, which is basically what it is. Like that is the essence of it. So we take this 3D view that we have in our viewport that we've been working on, we render it and convert it to a 2D image that we then can showcase. And if you're working with animation, you are basically rendering one frame at a time and then you're playing it back to give you an animation basically. So when you're working with rendering, you're working with a render engine usually. So a render engine basically simulates light bouncing in a space in combination with different materials, textures, and attributes, which in return then gives you a 2D image of the scene. So we will be placing out a light or some kind of light source, and our engine basically simulates the light bouncing around the space and then into our 3D camera that we created in the last couple of lessons in our previous section. So when you're going through this process, you will also be using yourself of materials and textures with different attributes that can then help you simulate different types of surfaces like glass, wood, plastic, etc. Now those attributes and textures will actually change how the light bounces within the scene, and that will give you a different effect. Like for example, a glass material, it won't just let the light ray bounce off the surface, it will also allow the light to bounce through the surface, bounce around within it, and then exit out on the other side, which will then make it transparent. And you might be thinking, does 3D rendering mean only simulating photorealistic environments? And the answer to that is, of course, no. Rendering also means, any type of stylized design. The same render engine can give you two completely different results. It's just about what kind of tool set and what kind of features you're using within the render engine that will then give you that result. So the process to get a rendered image out of 3D might look very different depending on what kind of style you're going for or who's the one doing it even. But I'll just show you a brief overview of how the process usually looks like. And in this step, you design and model your scene within any preferred 3D software that you're using. We have just finished this step, so we can move ahead from this. And that brings us to the lighting of the scene. And depending on the project, usually the lighting is done before any of the texturing. And that is because you want, obviously, to view your materials and your textures with your new beautiful lighting and not with, no lighting at all in the scene, because the appearance of the materials and the textures might look very different depending on what kind of lighting you have. So you usually try and nail that kind of stuff before you do any of the texturing or materials. Or you might come back to tweak the lighting once you're done with the materials and textures. Now you might light your scene in very different ways. That all completely depends on the look of the project and what you're trying to achieve. You can, for example, use, just a basic area light, which is kind of like a softbox that you would place in a studio. Or you can even simulate the sunlight that you would get from outdoors. Or you can use image-based lighting. And image-based lighting is basically where you take a 360 photo of some kind of environment using a very, very high dynamic range camera or photo setting, which can allow you to capture certain brightness values that you can then use to drive your lighting in your 3D scene. And the reason why you take a 360 photo of it is because then you can use it to project on your virtual sky within your scene, so you can then replicate the lighting in whatever environment you shot it in. Now, luckily enough, we don't have to go out and shoot all of these things ourselves. There are amazing resources that are both paid services, but there are also amazing free ones. So I'm going to show you one of the free ones today, and if you eventually end up using some of them for client projects, maybe think of donating something through their Patreon, because they are an amazing resource, and I know that a lot of people have them to thank for their amazing lighting. Anyways, the lighting of your scene completely is determined by what kind of look you're trying to achieve. In our case, we want a scene that is very bright and evenly lit, so naturally some kind of indoor HDRI might be the best solution for us. But yeah, once you are happy with the lighting, you usually move into texturing, applying materials, colors, and so on, until you get a beautiful frame that you can then render out, or move into animation and then render out your sequence. And as a beginner or someone who's starting to get into 3D, the majority of the questions that you get online usually is, what render engine do you use and why, basically? So I thought I'll answer that question once and for all. I have used all of these 3 engines, or V-Ray or Standard Renderer or whatever. If you are using, Redshift, Octane, or Arnold, you can basically get the same kind of result. It's just a different tool or a different way of achieving that result. In my case, I have been using Redshift for a few years. I used Octane before, and even before then I used Arnold. They are all amazing tools, so it doesn't really matter. But in this case, I will be using Redshift, partly because I personally like Redshift more. I just like the production-ready tools that you have. I like how fast it is, and I like how integrated it is to Cinema 4D. Since Maxon bought the company that does Redshift a few years ago, Redshift now comes with Cinema 4D, which is of course amazing, because then I can teach you all about it without you having to go and get a third-party plugin. So that's obviously amazing. But yeah, with that out of the way, I think we can move into Cinema and actually do some tweaking to our render settings and prepare our scene before we get into any of the lighting. So we'll go ahead and do that. All right, so we are in the scene that we have just been working with for the past few lessons. And before we get into any of the lighting or rendering or anything like that, we will need to change from the Cinema 4D standard renderer to the Redshift render engine. So to do that, we'll come up to this little gear icon here where it says Edit Render Settings. We will click that. And once you have that up, I'll just drag this window over here. I'll just expand it just a bit so we can see a bit better what we're doing. So naturally, I'll want to change this renderer from standard to Redshift. So I'll go ahead and do that. And once we do that, we'll kind of get a few different icons here. So right now, the default lights that we get are actually Redshift lights instead of standard lights. So that's great. So we won't be doing anything advanced in this course. So I won't be going through all of these different advanced settings. They basically contain all of the previous types of settings that you can edit before Redshift was properly integrated into Cinema 4D. But they contain a bunch of really good options if you want to, for example, optimize your rendering or add some render passes, which you can do over here. But I won't get into any of that in this course. There are plenty of really good resources on YouTube if you want to really get stuck into that. So I'll switch back to basic, where we have all the settings that we need. And we'll kind of leave these as they are because the settings are perfectly fine for what we're going to do. If you want to have some faster rendering when you're editing, you can set the bucket quality to low because then the rendering will go a bit quicker. So in the rest of our render settings, we'll have the output panel. And this is kind of where we decide our aspect ratio and the resolution that we'll be rendering in, our frame rate, what kind of frame range that we'll be rendering. And while we're here, I think we can actually go ahead and tweak some of these settings. And nowadays, usually when you are doing work within, motion graphics or 3D, the standard resolution that you work with is not really the widescreen format any longer, because usually you're making so much social media content that either you're doing a square format or a portrait format or whatever. In our case, I think since we just have a bunch of empty space on the sides, I think we can actually do a square format for our render, because I just think that makes more sense, and then you can kind of get a bit closer to the subject and see all of the tasty detail that we'll be adding. So for now, I'll change our resolution from 1280 720 to just 1080 by 1080. And if we want to scale this up later, we can do that as well, so that's fine. I'll just set that to 1080 and 1080. And as you can tell, that kind of changes the camera perception of our scene. So we'll go ahead and reconfigure our camera so we're a bit more zoomed in. So I'll just close this down, head into our camera, select it, go into coordinates and just zoom a bit in. So we'll just reframe the camera to a point where we're happy. So something like this. I want to have some clean space around her, but not too much. So something like 2,700 centimeters. All right, great. We'll hop back into our render settings and we can look at the frame rate. I will explain frame rate later down the line once we get into animation. But for now, we'll want to change this to 12 because I will be animating this in a lower frame rate, which will kind of give it this stop motion-y kind of look. So I'll change this from 30, which is default in Cinema, to 12. And while doing that, this will only affect the rendering output, but it won't affect the actual frame rate that we'll be animating within the scene. So we'll need to change that as well. So if I hit Control or Command D, we come into our project settings, and here we can see the time panel, and here we see the FPS setting. So we'll want to change this from 30 to 12, and that will kind of change the frame range amount since we have now decreased the amount of frames that we'll be animating and rendering. So that looks good. And then we also have the save panel here, and we won't be doing anything here yet. We will touch upon this a bit more once we actually render out our animation. So with that, I think we can actually go ahead and close down our render settings. And once we actually get into rendering and adding lights and so on, we won't actually be viewing our render within this nice viewport that we have been working in all this time. You will be viewing all of your renders in a separate window called the RS or Redshift render view here. So usually when I work, I have a separate monitor to the left-hand side of my screen where I then put this Redshift render view window on that entire screen just so I can view the render on its own while I'm working on the right monitor. You don't have to do that. I know a lot of people that don't have two monitors who are working, but that's just kind of the comfortable way I like to work. But what we can do instead is actually just dock our Redshift render view where our viewfinder currently is. So if we take this little hamburger icon here, I can just take this and drag it and drop it on the viewfinder panel as well. And that will kind of put them in tabs. So then I can switch back and forth between the Redshift render view and the viewfinder. And if you want to, you can also just put the render view side by side of the viewfinder, depending on how much real estate you basically have. This might be fine, actually. This might work better. Currently, I have scaled up all of my UI and all of my features on my screen just so you can see better what I'm doing. So I usually don't work in this tight of a layout, but we'll kind of have to do that right now just for the sake of the course and just to kind of show you what we're doing in a more obvious way. Now, by default, you probably have this set to original size, which is what it sounds like. It will output whatever you're rendering at 100% size, which is really big currently because we just have this small proportion of our screen allocated for this. So I'll just go ahead and change this from original size to fixed scaling. And that basically means that I can size down my render without just having to zoom out. Because if you just zoom out of the picture, you'll still render it at the high resolution, but only view it at a certain percentage. So in this case, I'm actually scaling down my render by 50%, which allows it to render quicker. So that's good. And you might be wondering, what are all these buttons doing? And I won't cover every single button. I'll cover the buttons that we will be using in this case. So the button that we will be hitting most of the time when we are rendering is the start and stop IPR. And that basically means start the interactive progressive render. And since we don't have any lights or any materials within our scene, this doesn't do anything. It kind of just shows this strange grayscale render that we have here. So I'll just go ahead and stop this. But if we were working in this and Cinema didn't notice a change that we were doing, then we can refresh the IPR. We can also view the different channels. If we, for example, had some different passes of our render added, those would be going in here. We can view the RGB and the alpha. So since we don't have any alpha, we're just going to see a white piece of image here. We can also select what parts of the image we want to render if we hit the region render icon here. In our case, for example, we are rendering from this camera. If I, for example, wanted to render from this angle, I can hop over here, activate the IPR, and then snap out of this locked angle so I can just render it from this camera. And then if I hop back, I can lock it in there, and then you can basically switch whatever camera you want to be rendering from in here. And since this is progressive, this will just kind of keep going until you make any change or whenever it reaches 100%. But if you want to view a finished render a bit quicker, you can hit the bucket rendering icon here. So that will kind of go through and add all of the passes and stuff and output a final image of your render. So if you, for example, want to view the high detail version of a certain texture, then you might hit the bucket rendering just so you can kind of see how it looks in a more finished state. So yeah, with that, I'll just go ahead and pause our interactive renderer here. So yeah, with that set up, if you want to save this layout that you've just set up, you can come up to Window, Customization, and then Save Layout in case you want to save it as a render layout or whatever, and then it will kind of pop up here. Since it's just a matter of docking one window, I won't be doing it in this case, but we might do it later on once we get into texturing. But yeah, with that kind of settled and done, we'll move into lighting in the next lesson. So I'll see you over there.